Okay, so there's no definitive and very simple guide as to how you should or can test your input signals on the Speeduino using like next to nothing, and this is what I want to accomplish with this video. So we're going to try and do that. I haven't set up any of the connections between the computer, Speeduino, the second Arduino. I'm using a Mega, but you can use an Uno or this, that and the other. I haven't set up any connections whatsoever, so I want to, because most of the videos that I've seen show the thing already completely set up, and if you literally haven't got a clue where to start, there isn't anything to show you how you need to wire everything together to start your testing. So we're going to do that. I'm going to talk about a couple of other things. Now, with setting up, you need, in order to simulate a crank signal, you need to get either another Mega like I've got, or you can even use an Uno, but you do need a second device that you can load ArduStim to in order to create that crank signal. That isn't something that I'm going to go into, and I'll tell you why. Now, there's two very good resources that I use. The first one is on Speeduino, and it is the ArduStim instructions for simulators. Literally is pretty much step by step with links for downloads, and you can see there that they are actually specifically talking about the Uno. So and that is probably the cheapest option. The reason I wanted to have a second Mega pardon me, is in case I actually damaged the original, so I've always got a spare. That's my reasoning behind it, but the Uno is probably the cheapest way to go. So Speeduino, the name of that post is ArduStim or ArduStim instructions for simulators on the wiki, or is it? It's either on the wiki or the forum. And then, in addition to this, because I was using the Mega, I used some information from tastelikepetrol.net. Speeduino testing is the link, and in here is some really good information. You need to read through it, but you need to add some extra lines of code for the Mega 2650. It's explained in this article exactly how to do it. Very nice. Therefore, I'm not going to go into that one crank simulator in any more detail, because there's loads about it, so have a look, no worries. Right, so let's go through what we need essentially to do some very simple testing. A 12-volt source of power. You can either use a little motorcycle battery like I'm doing, you can use a car battery, it'll work, or if you're lucky enough to have sort of electrical testing equipment that can provide a 12-volt signal, 12 volts to the thing, then that's what you can use. You'll also need a couple of wires for positive and negative to this main 12 volts and ground on the Speeduino. And in order to get a ground to the secondary board, you definitely need to ground that. So I just used a piece of wire to ground that. So let's go ahead and do that now. Right, so we've gone ahead and used the two wires, one to the positive terminal of the battery or whatever power source you're using, and one to 12 volts on the Speeduino. The other one, possibly you should use a red and a black, make life easier for yourself, but I've just denoted that this is the negative by putting a black tape over it. So we've got the negative from the negative terminal of the battery to ground on the Speeduino, and I've also installed our ground that's going to go into the second Mega for ArduStim. So what we'll do next is we'll take the ArduStim out, plug it into the laptop USB, we'll plug the Speeduino in with its USB cable. That's the next bit, so we'll do that now. Okay, that's that done. So we've got the Speeduino USB cable plugged into the computer. We've got the Argistim USB plugged into the secondary Mega. Now I've put this plastic bag here to stop arcing between the main ports for power here and this USB port on there. They did touch once, and I got a little bit of spark and nearly crapped myself, so that's why that bag's there. The other connection I've made is the ground to the ground pin on the Speeduino. Sorry, the Mega for Arduino. Apologies, my bad. Right, so pardon me. That's another thing done. Now, the only other thing we're going to need to do now is actually set up some lines for testing. So that's what we'll go ahead and do. No, in fact, what we'll do first is we shall load up the programs that we'll use on the computer. So I've already got Tuner Studio pre-installed. This is just the free copy at the moment. I will be buying the paid version because I want to do auto tune. And if you haven't done it before, you need to create a new project and load a new bass tune, but I've previously done that, so I'm just going to open the last project. Right, so there we go, simple as that is now connecting up, and that is effectively connected to the Speeduino. So the other piece, I'm just going to remove that for now. The other bit that I need is Druid for Arduino, so we'll fire that bad boy up, and that is the GUI, the user interface for the Argistim, or Argistim, I don't know how to pronounce that. So that's that. And just go and do a couple of really simple things. So we'll set it up with the correct wheel that it requires. I'm saying new wheel chosen, 60 to 2 crank only, because that's what I'll be using in the actual car. And go back to top and then set a fixed RPM. I normally put it somewhere around 700 because that's kind of idle-ish, and we'll do okay on that. Now when we do that and go back into here, we'll still have nothing presently. That's because we need to put a signal wire between port 53 there on your Argistim and the signal for engine speed, which is number 25, so that's 21 there, and count 5 along from that pin. So we go, and get my hand out of the way, we go 21, 22, 23, 24, 25, so number 5, let me just do it, and there we go, 25, that's the signal pin, and immediately both your spark LEDs and your injector LEDs will start flashing as long as everything's working correctly. And I'm also getting, I've put in 700 but I've only got 696 on there. It's a little bit off, but it's next to nothing off, so that's telling me that we've got an engine speed reference. Cool, so that's that sorted. Okay, so the next thing that we're going to do is we're going to test inlet air temp and coolant air temp with a potentiometer. Now you can pick these up for next to nothing. That's a very simple little potentiometer. Have a look on eBay or Amazon or wherever you buy your stuff from, or just wherever. They are dirt cheap, and that literally you only need one of these. You can buy more than that and like use one for inlet air temp, one for coolant temp, one for the TPS, one for your lambda. Yeah, so you could do one and then be able to test everything at the same time. That isn't necessary. You can get away with just using one potentiometer for all of your tests, and that's what I'll be doing because it's the very most simple way to do it and explain it to people that are very new to this like me. So one thing I didn't explain about is these little link wires. Again, eBay, bought that, which is an IDE40, otherwise known as DuPont set of cables, and as I need them I've just been peeling one off. They just peel away really easy. You just obviously pull them away and they strip into to one wire. So that's that. So right, in order to work out which pin we need to plug into on here, we need some reference. So that comes from the Speeduino wiki. I've already got it here. And you go into whichever board yours is. I'm in the 0.4 board stuff because that's the board I'm using. If we scroll down the physical layout, you've got your board pins here, and it tells you effectively exactly there. Number 1 is the top left pin all the way down to 20 on that side, and then we start at 21 on the bottom right, and it goes back up the way to pin 40. And then very simply we look at what we need. So if we were, say, to test the throttle position sensor for input, we'd use pin 22, and we can tell from here, so that's pin 21, that's pin 40, so it's counting up the way on this right hand side of the board, so 22 is the second one up there. So that would be where we put the input to the throttle position sensor. Similarly, if you, depending on what you're testing, you just scroll up and down, find what you need, and we're well away. So the first two we're going to be doing are coolant and inlet air temperature sensors. So let's set that up now. All we need to test for these two is the potentiometer and two of these wires. I'll pause, set that up, and show you what I've done. Okay then, so what I've done is I have chosen on the grey wire here, the correct pin for the coolant temperature, which is pin 19 down here, and I've put it to one of the pins on the potentiometer. I've also chosen ground in the proto area here, just to give the other side of the potentiometer a ground, and rather than using the pins that way, I've just popped the pin through the little circular hole on the potentiometer, and that's it. So that will now test coolant temperature. So as I turn this potentiometer with my thumb backward and forward, we'll see the coolant temperature going up and going down. So there's only two connections that we need to test that. So that's that tested. We know for a fact that the ECU is actually working for that. So the next pin for the inlet air temperature is pin 20. So all we need to do is move over to pin 20 on here, and we can leave everything else set up as it was. And now the coolant temperature up there, it's gone to its default broken state, 180. And the inlet air temp, now I'm going to do the same. I'm going to twist the potentiometer backward and forward, and we'll watch the inlet air temp. See, that's now nicely rising up and down as I twist the potentiometer, so we know for a fact that we're getting an input to the ECU, and the ECU is then output into Tuner Studio. So that's two of them tested. Excellent. Alright, the next two, you only have to add one more of these wires. Wait, just throw them everywhere. One more of these wires to do the throttle position sensor and the lambda sensors. One thing that I should have mentioned is that you'll see the duty cycle and the gamma enrichment moving with your other tests. So if I change the inlet air temperature down the way, see that gamma enrichment is 112, 114. So basically that means because the air temperature is cooler it's adding enrichment, it's adding fuel to, you know, effectively deal with that. And that of course means that your duty cycle for your injectors would go up, and then as the temperature rises it drops back down again, and so does your duty cycle. So that's how you know that those parts of the board are actually working as they should. So as I was saying, we are add another wire to this little potentiometer setup to test for throttle position and lambda, so I shall do that now and come back. Okay, so you'll notice now we have one more wire. We've still got a ground wire, we've still got this signal wire, which has been changed to the ones that we're using now for the O2 sensor and throttle position sensor are number 21 and 22. So I've moved the signal to 21 for O2 sensor. The only other thing we need for these two is a 5-volt reference, which is this one here that I've added, and that goes to 5 volts on the proto area of the board. So let's go back to Tuner Studio, and now if we look at lambda, and all I'm going to do again is twist the potentiometer. It's a little bit tricky with the 3 in there, but there you go. You can see lambda sensor moving backward and forward. Oh, one of my wires has come out. I've lost ground. Hang on. This is the only thing about it. If you do it without using a breadboard or anything, it is the very simplest way to do it, but you just got to be delicate whilst you're mucking around with the potentiometer or things pop out. Right, I'll put this back in and come back. Bear with me. Okay, back again. So now twisting the potentiometer for lambda. There we go. That's moving backward and forward. So we've tested that the oxygen sensor part of the board is moving. So the final thing we're now going to do is move down here on our pins to the next one along, which is 22, and that is for the throttle position sensor. So just hold the board, push that down into 22, and now when I turn the potentiometer we should look at throttle position, and that should move backward and forward. So let's try that. Oh, wires come out again. Hang on. Okay, right, now there we go, the throttle position sensor is moving. Have I lost a wire again? I don't think so, just a slightly dodgy connection. There we go, throttle position sensor moving up and down. So effectively we've tested all of the ones that we'd like to with the potentiometer. The engine map is obviously this is the map sensor which is on the board. You can just use the syringe to test the engine map backward and forward. So as you pull it, the needle will go one way, and as you push it back in, the needle will go the other way. Or you can try blowing on the thing, which I'll just show you now. I'll take the potentiometer completely out, and I'll put it to my lips. It won't move much, it takes quite a lot to do it, but it'll move a little. So that went to 111 kPa, so you can tell that it is working just by blowing on it. So that's the very simplest way to just test that you have that signal. Right, that was a little bit long-winded, and my camera work is shocking, so I apologise, but that's effectively how you test all of your input signals on that bad boy, and also how you wire it. So that should be hopefully of some help to somebody that is really fresh at this, like I was not very long ago. Alright, thanks very much for your time, and I'll try posting up some more stuff, see if you like it. Thanks for now.